Welcome to Madman Fungi. Recently, I've been reading Paul Stamets' book, Mycelium Running, and like thousands of others before me, I have been extremely inspired by what he's written about, and I would like to delve deeper into the concepts that he's talking about in the book. To start, I'm going to read the very first paragraph in the Mycorestoration section because I feel like it sums up the plot of this video very well. Habitats like people have immune systems which become weakened due to stress, disease, or exhaustion. Mycorestoration is the use of fungi to repair and restore the weakened immune systems of the environment. Whether habitats have been damaged by human activity or natural disaster, saprophytic, endophytic, mycorrhizal, and in some cases, parasitic fungi can aid in recovery. As generations of mycelia cycle through the habitat, soil depth and moisture increase, enhancing the carrying capacity of the environment and the diversity of its members. Now, my take on mycorestoration. Mycorestoration is an umbrella term that encompasses 4 scientific concepts at aiding the healing of an ecosystem through fixing different ailments in nature: mycofiltration, mycoforestry, mycoremediation, and mycopesticides. Something key in all of these concepts is selecting the right mushroom or fungus for the job, and to do so that most sufficiently, a good understanding of fungal ecology must be in mind. As I've stated before and will continue to do so, each species plays its part in the individual ecology role, so knowing what species to introduce and when is crucial for the success of the restoration project. There are three main types of fungi that offer something different in their own respective ways. First is saprotrophic fungi, the decomposers and the ones that set the stage for bioactivity and biodiversity, which can be broken down into 3 categories. The first one is primary, such as oyster mushrooms, shiitake, and maitake. Second, shaggy mane and Stropharia ambigua, and white button mushrooms, Agaricus bisporus, and tertiary or soil dwellers, Canosabe, Argosabe, and Mycena. What's really cool about fungi, especially these saprotrophic fungi, is that they all release a unique extracellular enzyme and acid concoction, meaning that a certain species can break things down better and more sufficiently than others. This idea becomes even more important for mycoremediation and mycofiltration. Each stage of the decomposition process breaks complex molecules into simpler forms. With each generation of mycelium, soil depth increases, moisture retention is increased, and the stage is set for microbes in the microbiome to begin doing their work, bearing new life into the ecosystem. Up next is mycorrhizal fungi, which I have talked about in other discussions, but I'm definitely excited to talk about mycorrhizal fungi again. Mycorrhizal fungi is actually aid in the growth and protection of the host species. They help gather types of nutrients from the soil like nitrogen, phosphorus, potassium, zinc, and others. And because fungi are very competitive against organisms that can harm the host, especially mycofungi because they need the host to survive, they're really efficient at transporting chemicals to the host rhizospheric microbiome because, like us, that is where a lot of the immunity defense takes place. A few examples are amanitas, king boletes, chanterelles, gypsy, hedgehog, aspen boletes, and truffles. With regards to mycoforestry, the mycorrhizal choices that are made, along with which saprotrophic fungi to begin the process of decomposition, are absolutely crucial to the success and the quality and quantity of rebuilding the units of forest that have been harvested. I recommend looking into an experiment called the SimArt experiment. It shows that different species of ectomycorrhizal and arbuscular mycorrhizal can transport nutrients and water between 3 different tree species. A forest health is directly impacted by the presence, abundance, and variety of mycelial associations. Even parasitic fungi, such as the honey mushroom, a variety of Armillaria species, and the microfungus Phytophorum ramorum, can have certain benefits for the forest. Parasitic fungi can act as nature choosing the strong to survive and moving the weak into a place of benefiting the environment. For example, a rotting tree has more to offer in biodiversity if it's being food for other organisms rather than soaking up the nutrients, water, and sunlight trying to stay alive that could otherwise be used for healthy trees. Parasitic fungi aren't always a bad thing, as they can clear units of forest to create meadows for herbivores to thrive, allow understory vegetation to get their share of sunlight and nutrients, and can even create fire breaks. In the case of Armillaria, it can act as both parasitic and saprotrophic. Many trees can be wasted by the lumber companies because of parasitic infection. So using the competitive nature of mushrooms, mycoforesters can contain the spread of parasitic fungi. For example, in the nature you can find smoky woodlovers, Hypoloma capnoidus, and fascicular growing on the outside boundaries of Armillaria blights. Cauliflower mushroom, Spiraceus crispa, grown in a petri dish with Armillaria, can completely overwhelm the mycelium of Armillaria. However, in sections of forests that are blighted by Armillaria, nurse logs are created, soil depth is increased, and rich habitats follow. The complex biology of fungi, and through the power of the earth, mushrooms and fungi have become the great grand composers of the orchestra ecosystem. When the land has been scorched by fire, by natural cause, or a prescribed burn of slash, the great morels and cup fungi, Auricularia, are the first to help bring insects and birds, which then bring seeds and spreads the spores of these fungi elsewhere in the ecosystem. Or after a large logging operation, mushrooms are the first to act in recycling the materials so that new life can arise and support the growth and sustainability of new life. Fungi steer life in the direction it wants, and for life to go is intelligently doing so in the long-term benefit of ecological health. Perhaps something we all should start considering. Thank you very much for watching, and I really hope you enjoyed this video, and I hope you learned something. Thank you.